G'day, welcome to the 2015 Extension 2 Mathematics HSC. Let's try and go through the whole lot. Question 1. Which conic has eccentricity root 13 over 3? First thing you should look at when you've got the answers, you've got two pluses and two minuses. So these pluses, your automatic thought is those two are ellipses and these ones are hyperbola. Okay, that should be your first thought, or possibly your second thought. Your first thought may be, what is that eccentricity? And root 13 over 3, if that was a 9, root 9 over 3 is 1. This is therefore greater than 1. So this is greater than 1, which means it must be a hyperbola. Okay, so automatically you can wipe those two out. Next thing you realise, so they're out. Next thing you realise is you've got squareds there and you've got a non-squared on the bottom, and you should realise by your formula when you've got eccentricity you've got a squared and you've got an a on the bottom. Okay, so that's a squared plus b squared, so that's your eccentricity for a hyperbola. So automatically you should be looking at it and going, okay, this must be my answer. Okay, your answer is D. The plus, it doesn't matter, but that minus sign's there, you're just plussing that value. So that squared plus that squared in there is going to be your root 13. But this is your key. Your key is, that's the A, not the A squared. That's there. So your answer is D. G'day, back again. Question 2. What value of z satisfies z squared equals 7 minus 24i? In this sort of question, I don't think it's worth trying to figure out what is the square root of that. You can if you're really good at that, but I wouldn't. I would just simply grab these, each one of these, and square them. So let's do that. If you're going to go 4 minus 3i multiplied by 4 minus 3i, 4 times 4 is 16. 4 times minus 3 is minus 12. We're not going to double that because we get it twice, so we're going to get minus 24i. Minus times a minus is a plus, so we're going to get plus 9i squared. I squared is minus 1, so that is going to turn into a minus. 16 minus 9 is 7 minus 24i. And yes, you've immediately got your answer. So in this case, the examiners have been kind by putting it as A, but let's say it wasn't A. Let's say that was actually a plus. You get that, you do that with the first one, and you go, okay, there's only got to be one change to this, and that is, that's got to be a plus. Once you start doing the second one, you actually see minus 4, minus 4. The only thing that changes, minus times a minus is again a plus, is going to be this one. So in that case, if it was a plus, B would be your answer. And I think the speed of you doing that is much faster to square it rather than trying to sit there and figure out what's the square root. So in this case, A is your answer. G'day again. Question 3. Which graph best describes y equals brackets x minus 1 all squared, brackets x plus 3 to the 5th? I would consider this probably the easiest question on the paper, simply because of the answers you're given. If you just look at this and consider, where's the root? Well, if you've got x minus 1 squared, where's the root going to be? Well, there's going to be a root when that equals plus 1. Because it's a squared, it's a double root. So if it's a double root, you should know, again, pretty basic from year 10, that that's a double root, and that's a double root. Okay, because it touches the x-axis. And it only occurs once in the answers, it doesn't occur in any of the others. So your answer is pretty easy, it's A. G'day, question 4. The polynomial x cubed plus x squared minus 5x plus 3 has a double root at x equals A. What's the value of A? Two ways to do it. First way is put each of these into that equation. And what you happen to find is if you put them one at a time into the equation, you put that in, you end up with 0. You put minus 1 in, you end up with 8. You put 1 in, you end up with 0. You put 5 on 3 in and you end up with 56 on 27. And that would find you 2 roots. That's a cubic, you know, one of them is a double, so you can continue on. I wouldn't rely on that method because you might only get 1 root. This, you know, might be 2 or something, and you might only get 1 root. So you need to have another plan of attack. So in this case it works and we've got the 2 roots, but let's say that number was 2 or that was a different number, so you only got one of the roots in the answer. What you need to do is simply differentiate it. So differentiate that and you're going to get 3x squared plus 2x minus 5. If it's a root, differentiate it, put it equal to 0. So y dash will equal that, put it equal to 0. Now you should be able to look at that and go, okay, there's only going to be a 3 multiplied by 1, and there's only going to be 5 multiplied by 1. So you're not going to have too many choices if it works exactly without using the quadratic formula. And in this case, I would try factorising first. So 3x, you're going to have a 3x there and an x there. 5, you're going to have a 5 there and a 1 there, or a 5 there and a 1 there. 5 times 3, if you do that, is 15, which is way, way too big. So let's put the 5 there and the 1 there. We want this to be positive, so the greater number will be positive. That's negative, and 5x, take away 3x, is 2x, and that works. So this gives you your 2 roots. So your roots are x equals minus 5 on 3, or 1. And in this case, there they are. Okay, so that would be your first step. This would be, if you got lucky and the examiners were pretty nice. Either way, you've now got your first step done. You want to go to the next step. It's a double root. You should have learned double roots in year 10. What's a double root? Well, a double root is where you get a graph and it's either going to do this and touch the x-axis there, or it's going to do this and touch the x-axis there. That's x, that's y. Okay, that's a double root. It's touching twice. A single root will pass through. So you know that one of these is a double root. So I would simply draw it and say, well, that's minus 5 on 3. That's 1. They're my 2 roots. I know they're going to pass through the x-axis. How can I sketch it? Well, pretty simply, I would start by putting in 0, because that gives you what point's in the middle. 0 plus 0 plus minus 0 plus 3. Well, that's going to be a 3. So we're going to have a 3 there. So that tells you that this graph will go like that. Now you don't know whether this side's going to go up or this side's going to go up. One of them's obviously going to go down because it passes through it, because you can't have 2 double roots in something which has only got a power of 3. So which one's going to go up? Just put another point in. Let's try 2, put in 2, and what do we get? 2 cubed is 8, 2 squared is 4, minus 10, 5 times 2 is 10, plus 3, that's 12, take away 10 is 2, 2 plus 3 is 5, so this point here is at 5, so that must go like that. So that's your double root. You don't have to check this, you now know that's going. If you check this, and even if you look at it, you pick a big negative number and you put it in the cube, well, it's going to stay negative and be negative, so it will drag it down there. Okay, so your double root is C, and you're done.